what we're going to be looking at with 6-4 day 1 is going to be what we call transformations of graphs. How many times have we done transformations this year? A lot. The only difference is we're going to deal and focus on just exponential ones today. There's a little bit of a tweak to it as compared to what we normally had. Do you remember that template I gave you a long time ago that I gave you right before finals for semesters? And how it had all those little boxes? I'm going to do the same thing except for I'm going to put the tweak in there. Okay? What does a minus on the outside do for our problem?
Reflection.
A negative in the front would be a reflection over the x-axis. What's a number multiplied on the outside do?
Vertical shrink or stretch.
Vertical stretch. If that number is bigger than 1, oh, I'm not going to put B, I'm going to put A. And a shrink if that number is between 0 and 1. Then I'm going to put a B there. The reason why I'm going to put a B is it's for standing for the base. Will the bases change? Yes. Okay, but we're talking about exponentials. So that's why I have to have the base there. It's kind of like your hidden parentheses. Remember how we had this before, that template, where now I put a big giant set of grouping symbols? The B is like a parentheses. And where is the next piece going? It's going in the exponent. The exponent, you guys, is the grouping symbol that you're referring to. So what if there was a negative in front of the x? On the inside. What did we say a negative on the inside did? Reflection. Which way? Over the y-axis. Okay? Then there might be a number multiplied on the inside. What's a number multiplied on the inside tell you? Good. Horizontal stretch. If that number is between 0 and 1. And a horizontal shrink if that number is greater than 1. Then you will have an x. It's Mr. Feldner's class. They're doing some sensory testing.
Oh, yeah.
Okay? Huh? It's a negative in the front, right? That means the reflection over the y-axis. Now, what would be an adding or subtracting on the inside? And this is where, Jordan, I think you were earlier. What's an adding or subtracting on the inside of the exponent do? Adding goes left, minus goes right. And then now on the outside of the whole thing, what's an adding do on the outside?
Up.
Up, down. So, and I know that's what you were thinking of earlier. So if you look at my template, it's a little bit messy, but did it really change from what we dealt with in day 1? No. The only thing that's a little bit different is the parent has now changed where the base is in there. And instead of having a big giant set of parentheses, now we're just looking at it as that's the exponent part. The directions for almost every question you're going to have today is going to say this. Describe the transformations that take place, sketch the graphs. Have you done that for me before?
Yeah.
How many times have you had to describe the transformations and sketch the graphs? Every chapter you've done this for me. So it's not anything new. The only thing that's new is the parent. So has everybody got the template okay? All right. So here's what it's going to have. It's going to have something like f of x is equal to 1/2 to the x power. G of x is going to equal 1/2 to the x power minus 4. So first thing I want you to tell me, what transformation took place from the top one to the bottom one? What, Emma? Down 4. Nice job. Okay? Now, notice, what's in the base is the 1/2. Okay? That is not part of a transformation. The half is not part of a transformation. That is the base. Okay? So is 1/2 to the x an exponential growth or decay?
Okay.
It's a decay. Right. So the first thing that I'm going to do is I'm going to draw that parent. Remember how it said graph each of them? Always? And we said an exponential decay comes through this point at 0, 1. This was like last week material stuff. And it came down here, swung through there, and rode all alongside there. When it rides along the x-axis, I told you about a word last week, and you probably missed it, but that's okay. When that rides along the x-axis like that, that's what we call an asymptote. Do you remember me saying that word now? Okay, with asymptote meaning that it comes right up to it, but it can never cross it. I talked about the invisible dog fence. Okay. Now, if I shift everything down 4 units, instead of crossing at the ordered pair of 0, 1, where's it going to hit now? Instead of hitting here, move down 4, right? Just count. 1, 2, 3, 4. So where does it hit now? 0, -3. We went down 4. Now remember that line that it rode alongside? The x-axis? That also pushes down 4 units. 1, 2, 3, 4. It's like there's an invisible line running east and west there. Okay? Me personally, when I'm graphing these, I will insert that asymptote just so that way I don't cross the line. Okay? If you don't put it on there, I'm not going to hold it against you, but it might be beneficial to you. Okay? Now, what am I supposed to do with the blue? Do I make the same curve just in a different location? Isn't that what shifting does? Doesn't change the size or shape. So it should be roughly the same curve, just in a new location. As best I can. What do you think? What are your thoughts? Not too bad? Here's another little question for you. All of these today are going to be exponentials. You are not going to have to graph a logarithm at all today. Can you put every single one of the graphs in your calculator? Yes. So if you wanted to put both of those in the calculator, could you do it? Mm-hmm. Yes, you could. I know you could. Okay. F of x this time is equal to e to the x. G to the x this time is e to the x plus 3 plus 2. I want you guys to do this one. Okay, once you guys get done, share with your groups what you guys got. The exponent is like left and right.
I graphed one of them. It's like legit in the middle of the thing.
Okay. Is that enough time? Everybody got an idea? Okay, group number 1, which happens to be this lovely table right here. Who wants to try? Gabby? Okay. Gabby, go ahead.
What do you want
I
me to
want
do?
you to write out or list out the transformations that take place, and then sketch both graphs. All right, so let's see what Gabby had drawn up there. Okay, she's got, first of all, she's got a left 3 and an up 2. And g to the x equals 3 to the 3x minus 5. Okay, again, I'll give you a little bit of time to work on it on your own. Once you get done, share with your group so that everybody knows what's going on. Again, you're going to list out the transformations that took place and sketch both graphs. That is the directions for 90% of your assignment today.
Yeah, she wants to fire Matt. No, that's. We only have one guy. The guy with the Achilles. She don't like him. She's firing anybody else. I don't know who she's firing, because I'm gonna be real mad fucking.
She's like, hey, how we doing? Need more time? Close? All right, let's see how we did. Okay, so 1, 2, 3, 4. Kristen, did you get a chance to get it? No? Okay. Ready from you guys. 1, 2, 3, 4. Actually, 4, 5, 6 would be there. Nicole, did you get a chance? Okay, Nicole, what do you think is going on? Here, why don't you write it for me? Okay? So in case you didn't hear Nicole, sometimes she gets a little quiet when she talks. Alright? She said something like a horizontal something, and then something else. Thank you. Alright, so she's got a horizontal shrink by 3 and right 5. What do you guys think?
Am I supposed to draw it?
Okay, hold on, I'll draw it for you. I gotta change something. Okay, she is really close. If you had this, you would be really close. The right 5 is awesome. Okay? But anytime you do a horizontal, anytime you have horizontal stretch or shrink, it's not the number that you put there as 3, you got to put 1/3. Okay, so anytime you have horizontal, you're reporting out the reciprocal of whatever number was in the multiply. All right? which she changed after I said something and then she remembered and she said it just to me where I heard it. Okay? Now, when I'm going to sketch that graph for her, and I'll do the graphing because I know sometimes it gets a little crazy. According to the original one, the purple one, 3 to the x should have went right about here-ish, just like the last ones and almost every single other one. According to this, right 5 and horizontally shrinking it by a third. And that means horizontal shrinking it means that if I were to grab the left side and grab the right side and squeeze it, what would happen to the graph if I squeezed it on the sides? And what happens to a orange when you squeeze it? It lets out the juice and gets skinnier, right? Gets flatter. So what should happen to my purple curve if I'm squeezing it from the sides? It should get what? Skinnier, meaning it probably should go up faster. Right. Okay. And we're also going to go up or right 5, which means instead of crossing here, if we go right 5 and we squeeze it, it should look something straighter or flatter, almost like a 90-degree corner as compared to the rest of them. So we've done at least 3 of them that are like this. How are you guys feeling? I'd say probably 75 to 90% of your assignment is doing this. Are you guys okay with that? Now, the other part to it, the other 25 to 10%, I can't remember what exactly it is going to have you doing this. Tell me if you've seen this before. Let the graph be a reflection over the x-axis, followed by a translation 4 units to the right of the graph f of x equals 2 to the x. So what am I asking you to do? I'm asking you to write the new equation. Have you guys done that for me before? Yes, just about on every test that we've had these, correct? So, where does the reflection on the x-axis go? Outside. So negative and then 2 to the x. That's the first piece. Second piece said, followed by a translation 4 units to the right. Where does right 4 go? With the x. Where's the x at? In the exponent. And so which way is right? Is it plus or minus? Minus 4. Have you created the new graph then? Yes. All it's asking you to do on the last 3 questions is come up with the equation of the new one based on the transformations that were given. Have you done that? Yes. What do you think? What are your thoughts? Your feelings?
Not bad.
Not bad? Give it a try and see what happens. The majority of your assignment will say, describe the transformations that take place, then sketch the graphs. And then the last part of the assignment will say, given the transformations, find the new equation. Okay? So again, that's nothing that you guys have not done for me before. The only difference is this time it's a new parent. So on page 322 to 323, 3 to 24 multiples of 3. And then 35 to 37. Those last 3 questions are the ones where you have to write the equation. 3 through 24 multiples of 3, those are the tell me what happened and draw both graphs. Okay?